Assalamu alaikum, my dear student. Today our topic is law of refraction. First, to understand who is the discoverer of law of refraction. The actual law of refraction was discovered in the early 1600 by a Dutch mathematician and geodesist Willebrord Snell van Royals. Because the law of refractions we also called Snell law, because Snell law on the name of his discoverers. Okay, we understand law of refractions from two definitions. This is first definitions and this is second definition. What is first definitions? The point of incident normals at the point of incident and point of refraction all lie in the same planes. Okay, how we defines clearly means understand from figures. This is a air mediums and water mediums. Air medium also known as rare mediums and water also known as denser mediums. This is a incident ray, and this point means this point on the boundary of uh, fall on the boundary of point O. This point is known as point of incident, and this is a normals. This is a normals. And after falling they refract from rare to denser. Rare to denser. Mean rare's line is this type, but when light enter from rare to denser mediums, they bend toward normal. They bend toward normals. I already make a video on how light pass from air rare to denser and denser to rares, why bend toward normals and why away from pass away from normals. Okay, check on playlist. But here we only discuss law of refractions. Means the point of incident normals. This line is normals. Fall on the point of incident. This is point of incident and fall on a point of incident. And this point means this lines separated denser mediums and rare mediums. Okay, this is boundary between the denser mediums and rare mediums. Okay, understand? And this is angle of incident and this is angle of refractions. Mean angle of incident only draw with normals, and angle of refracted we all or we only draw from normals. That is the reasons. Okay, understand? Mean the point of incident at the point of incident and point of refraction all lie in the same planes. Point of incident and point of refracted lie in the same plane, lie in the same plane. Then we already defines another way, the state that the incident ray, refracted ray, and the normal all lie in the same plane, all lie in the same plane. Understand? And second definitions with the ratio. Mean the ratio between sine of angle of incident to the sine of angle of refraction is always equal to a constant. Always equal to a constant. Means this is a sine of angle of incident. I draw with normals and point of refracted. Sine of angle of refractions. Only draw with normals. The This is the ratio between sine of angle of incident to the sine of angle of refraction is always equal to a constant. Means what is constant? Constant knows this is sine I over sine r is equal to constant. Constant means refracted index. Refracting index. We already know what is the refracting index of air. Refracting index of air is always equal to 1, and refracting index of waters is always equal to 1.333. Okay, and we use this definition is also known as Snell law. Snell law. Mean this is equal to refracting index, and refracting index is equal to reflecting index of second medium divided by reflecting index of first mediums. Then we use here is equal to sine 2 over sine 1. This is cross multiply and is equal to sine theta, means this is always by cross multiplication is equal to n1 sine I is equal to n2 sine r. Means if we know the angle of incident and angle of refractions and also know the first medium reflecting index, then we find the reflecting index of second mediums. Okay, n1 sine theta I divided by sine theta r. Okay, understand? This is also a way we already know the reflecting index when ray enter from rare to denser mediums, and how ray enter from denser to rare medium. First, to understand, when light enter from rare to denser mediums, then the Snell law is equal, and in these shapes, means n is equal to n2 over n1, and this figure we already draw. This is rare mediums, denser mediums. Okay, and when light, means this figure is not correct, draw here. Okay, this is normals, and when enter from real to denser, they bend toward normals. This formula, this types. But when light enter from denser to rare mediums, then light bend away from normals. Mean this is denser and rare mediums, and this is incident, fall on normals, they bend away from normals because they enter from denser to rares. That is the reason they bend away from. Then is equal to in these shapes, mean 1 over n is equal to sine I over sine r, and n is equal to n2 over n1. Okay, understand? Clear?